So, the next part of this chapter is motional EMF. I think you already know with the meaning of these terms. The EMF induced across the ends of a rod due to its motion in a magnetic field. This is called as motional EMF. We categorize this into two cases, one in which the rod moves in a straight line translational motion, and one in which the rod rotates about its axis, and that is rotational motion. And for both the cases, we will determine the magnitude of EMF and the polarity of EMF both. So, let us quickly write these expression for the two, and then of course, we can extend those definition of EMFs for the calculation of current, forces, and so on. So, motional EMF, the first thing, whenever a conductor moves in magnetic field, the EMF, the potential difference, let me write it completely, potential difference is induced across its ends. This EMF, this is called as EMF or motional EMF. So, it means that rod will work as a battery. The value of this EMF is rate at which the rod is cutting or crossing magnetic field lines. So, the expression becomes dE will be equal to B dl BV times dl. This is the expression of EMF. When you integrate, E becomes BLV, simple BLV, where V is the velocity of the rod, L is the length of the rod, and B is the magnetic field. Now, my dear students, I would like to add one thing here, and which is perpendicular. Whenever you calculate the EMF, due to motion, then B, V and L, magnetic field, velocity and the length of conductor should be taken as the perpendicular components. Irrespective of their length, we have to consider only the mutually perpendicular components. So, make sure this means where these are the B perpendicular, V perpendicular and N perpendicular are mutually perpendicular components. Remember. And from here we are going to add one more important point regarding this. Suppose if there is no mutual perpendicular component, suppose if the magnetic field becomes parallel to conductor, suppose if the velocity is along conductor, suppose if the velocity is along magnetic field, then EMF will be 0, because there will be no perpendicular component, then there will be no EMF. So, if any of two pair 2 becomes parallel or same direction, then EMF will be 0. There will be no potential difference across the ends of the rod, no EMF at all. Make sure you understand this point. So, BLV, where B and L and V are perpendicular, mutually perpendicular to each other, or if any two of them become parallel, EMF will be 0. For example, let me give you examples of 0. Suppose this is the magnetic field What is this? This is the magnetic field, okay. And suppose this is your rod of length L. Now you can clearly see that length is perpendicular to magnetic field, but if you move this rod along magnetic field, then potential difference across A and B, EMF across A and B will become 0, my dear students, because velocity is parallel to magnetic field. Simple, no EMF will be generated, because the velocity, if you move it along magnetic field, then no EMF. Further, for example, this is magnetic field, this is magnetic field, and let us say this is your rod. You can see again the rod and magnetic field are perpendicular to each other. You can see the magnetic field is perpendicular to this plane on which in which the rod is kept, and its points are A and B. Now my dear student, if I move this with velocity like this, then again EMF across A and B will be 0, because this time velocity is parallel to length. You can clearly see if you move a rod along its length, no EMF will be induced, because B perpendicular, L perpendicular and V perpendicular will be 0. So remember these two cases, this will help you that why does sometimes EMF across the end of a rod become 0, because any of the two quantity may become parallel to each other. Yes, if in this case you move it in this direction, then of course there will be EMF across the ends of the rod, and that is what we need to determine. Now let us write few important notes regarding this. Note number 1. The first note is, when you write EMF will be equal to BLV, where B perpendicular, L perpendicular, V perpendicular, then this EMF will have polarity. The polarity of this EMF, the positive polarity of this EMF will be determined by V cross B. So if you want to determine the polarity, in which direction the positive there will be a positive polarity, then take the cross product of V velocity and magnetic field, then direction in which your thumb is will be positive polarity. Basically this is the direction of force, if you can recall, and from force this electromotive force is generated, and that is why we take the direction. For example, very simple example, suppose if there is a magnetic field like this, there is a magnetic field present in the space like this, and our rod is, you are moving a rod in this direction. First of all, check all the things are perpendicular to each other or not. Yes, they are perpendicular to each other. We have to write the perpendicular components. Now we would like to decide which is positive, which is negative, then for that, my dear students, you have to determine the direction of V cross B. So velocity, put your fingers along the velocity and curl them towards the magnetic field. You can see the direction V cross B comes out upward. So it means this is positive polarity and this is negative polarity. Suppose in the same magnetic field, if you move this rod upwards, then again to determine the positive polarity, put your fingers V along V, curl them towards B, V cross B direction. So V cross B, this is the direction positive polarity and this is negative. So why do we would like to know the polarity? Because my dear students, we can represent this as a battery of positive terminal upwards and negative terminal downward, and if it is connected to some resistor or capacitor, we can determine the induced current. Similarly, in this case we can visualize it as a battery with positive terminal towards the positive polarity, and if suppose it is connected to some resistors, then we can determine that okay, this will be the direction of current. So, determination of positive polarity is a very, very important technique. Second, rotating rod. So, basically in the case of rotating rod, for example, there is a rod which is rotating, it is a rod of length, it is hinged about the center, and you have started rotating it in this direction. Then of course EMF will be generated across the ends of the rod, and for that there should be magnetic field in this region. Let me assume magnetic field is inward. So in this case, my dear students, what we do, we use the basic formula. Basically you have to remember the results, but you can see if we divide this into many different small parts, each part will have different velocity. The parts which are away will have higher velocity as compared to the parts which are near to the center. So each of this V cross B, if you can see, this is the velocity V cross B, each of this will have plus minus plus minus plus minus plus minus plus minus. It's like so many small batteries are connected. So DE you can write as B into V into DL, everything is perpendicular. So from here DE will become B into, you can write V velocity at any distance r as velocity will be equal to omega r. So this will become omega r into dr. So integrate, EMF will become B omega r square by 2, whereas the r is the distance from the center. Remember, where r is the distance from the center, where r is the distance from center. Now you will remember this formula directly, B omega L square by 2, and to determine the direction of positive polarity, so positive polarity determination will be done using V cross B. Take the velocity of any point, for example in this case velocity of any point is upwards, then V cross B center will be positive and this will be negative, and the potential difference will be equal to B omega r square by 2, where r is the distance from center. Let us try to understand it better. For example, we have some rod of length 2L which is rotating about this end. Now the direction of rotation is this, magnetic field is again downward direction. Then my dear students, we know the potential difference EMF will be due to rotation of rod will be B omega r square. What is r? Radius. So in this case the radius is 2L, so 2L square by 2. Now we have to decide which is positive. So for that we have to identify the direction of velocity, we have to identify the direction of magnetic field V cross B. So when you take the V cross B, you can clearly see that this is the positive direction and this is the negative direction. So basically there is a potential difference between higher potential will be at the edge and lower potential at the center. Okay. Now for example, sometimes what they do, they may ask you that find the potential difference between two endpoints. So this is a rod, this is a center, let us say this is rotating about omega, and the magnetic field is let us say this time magnetic field is outward, dot represents, dot is the magnetic field outward direction, and they want to ask what is the potential difference between the midpoint and the end point. Let us say this is point A and this is point B, and they are asking us what is VA minus VB. Then my dear students, basically in this case you have to assume center as the reference. Always assume center as the reference. Why? Because we know the potential difference across A, let us say this length is total L, then L by 2, then potential difference across A will be equal to B omega L by 2 whole square by 2, that will be E at A, and E at B will be equal to b omega L square by 2. So basically, my dear students, don't just take this distance directly L by 2, because the formula is applicable between the center and the end point, between the center and the end point, not between any 2 points. So that R in formula b omega L square by 2 is the distance between center and the end point. So you have to take the center as a reference and then calculate the EMF of each points independently and then take the difference. So this is the understanding of motional EMF. Now let us solve few problems so that you will understand how these two simple formula can be applied in varied problems across the chapter.